Rainy and foggy.
Sunny, rainy,
Yeah,
and foggy.
and fog. Sorry, yeah, sunny, rainy, and foggy. So today's weather depends upon the previous day's weather, or tomorrow's weather depends upon the today's weather. Okay, so that's a Markov chain model. 1 minute. So I have given a problem. Now I'll give a problem. So each state depends upon the previous state, right? 1 minute. Can you all able to see the screen, students?
Yes, ma'am.
1 minute. I think I am loading multiple things, so it's stuck. Got stuck. So three types of weather we have. So sunny, rainy, and foggy. So they will be giving the today's weather and tomorrow's weather. So based on today's weather, we can predict tomorrow's weather. Or they will give yesterday's weather and today's. So based on yesterday's weather, we can predict today's weather. Okay. So based on the first order Markov model, each state depends upon the previous state. So if I want to, so if I give today's weather, if I want to predict tomorrow's weather is okay. If I given today's weather, if I want to predict day after tomorrow. So how it can be done? One level above. So day after tomorrow's weather depends upon
Tomorrow's weather.
tomorrow's weather. Tomorrow's weather depends upon
Today's weather.
okay. So given today's weather, if they ask you to predict day after tomorrow, directly you cannot go like this. So what you have to do? Day after tomorrow's weather depends upon tomorrow. So for tomorrow's weather, it has to depends upon
Today's weather.
today's weather. So it has to go like this. So I'll give an example now. Wait 1 minute, it's not loading. Internet is also, system has stuck. Yeah, it came. 1 minute. So see first order Markov, please take this example. Q of n to n is the nth day depends upon n minus previous day, previous to previous day, previous, like this it goes on. So in first order Markov model, generally it is written as P of Qn depends on Qn minus 1. So nth day depends upon n minus 1. So n is today. Today depends upon n minus 1 yesterday. Okay, like that it goes on in first order Markov. So take this example, take this table. Please can you all draw this table in your notebook for the, it is required for the next problem. So what is given here? Today's and yesterday's, or today's and tomorrow. So Qn and Qn plus 1, or Qn and Qn minus 1. So in this table Qn and n plus 1 is given, or Qn and n minus 1 is given. Please respond, students.
N and n plus 1.
N plus 1. Why it is n plus 1? N is today.
Because it's tomorrow.
Tomorrow is n plus 1. Sometimes it is given as yesterday. So if it yesterday means n and n, Qn
Minus 1.
minus 1. Good. So please take note of this table, and I told you how to draw this diagram. After taking this table, please draw the diagram. First step, they will give a table like this. Given a table, using first order Markov chain, draw the state diagram and find the probability of the weather day after tomorrow's weather given today's weather, like that. Their questions will be given. So first step, you have to draw the state diagram. Okay, so this diagram will not be given, only this table will be given. Please make note of this table. I will be moving to the next slide. There the values will not be there. After taking this table, draw the state transition diagram. Transition that will carry it on 2 marks. What is the state transition diagram? It has nodes and edges. Nodes are represents the states. What are the states we have in a weather? Sunny, rainy, and foggy. So 3 states are represented by a circle, and there is an edges are represented by the arrow lines connecting from one state to another, and above that edges we will be writing the values which is given in the table. And there is a self-edged loop. This means what? Sunny to 0.8. What is the self-edged loop? Sunny to sunny means what? What is this loop? Within that node itself, the loop starts in the same node and ends at the same node means what?
If today it is sunny, tomorrow also.
It is today is sunny, tomorrow is also sunny. Is what is the percentage? Probability is 0.8. Okay, so this is a state transition diagram. Please take this table and put the answer. First thing, for this table you have to draw the state transition diagram. That will not be given. Sometimes instead of table they will be given the diagram. So from the diagram also you can take the values. Okay, if the diagram is not given, table is given, is please make a note. If a table is given, you have to draw the diagram, then you have to proceed the sum. If the table is not given, sometimes instead of giving the values in the form of a table, they will be given in the form of a state transition diagram. The weather, okay, the probability of the weather is given in the form of a state transition diagram. So using the diagram, find the weather, tomorrow's weather given today is sunny, what will be the weather tomorrow? Like that they may ask. So this means that what are the states you have to identify if the diagram is given. How many states we have for weather? If the diagram is given, so how many states we have for 3 states? Sunny, foggy and rainy. And for each state to transition from one state to another state is given by a labeled arrow. It's an arrow mark with labeled values. Okay, to represent the probability that. Okay, so now we'll move to the question. Given that, take this question and I want you to solve, and any one of you has to tell me the answer. Then I'll show the answer. You give a try. Even if it is wrong, that is fine. Given that, take the question. First question. This is a problem. Given that weather for today and tomorrow is given in the form of a table. First thing, draw that state transition diagram. First question for this table. First question, draw the state transition diagram. Have you all drawn the diagram in your notebook? Yes or no?
Yes, ma'am.
Yes. Second question, for the same table, for the weather table, given that today's weather is sunny, what is the probability that tomorrow is sunny and day after is rainy? And day after is rainy. Can anyone give a try? I'll give 2 minutes.
Tomorrow is sunny since 0.8, day after tomorrow is 0.05.
You tell me the final answer. Give 2 minutes. I'll give 2 minutes. You solve it in your notebook. Then I'll show the answer. Then we will discuss. Think and do. Don't directly write it. Okay. Given today's weather, and the table has today and tomorrow. Okay. So today's weather is sunny. And what is the probability that tomorrow is sunny and day after tomorrow is rainy?
Point 0.04, ma'am.
I don't know the answer. I have to check it, but everybody is getting 0.4? 0.04, huh?
Yes, ma'am. 0.04.
Okay, I don't know. I have to solve it now. Can I move? So what is, so first you have to write, like you cannot write the answer directly. If you are writing the answer, see, even in your T1, many has written the answer directly for P of UT given. I have not given marks. Even all 3 answers are correct. I have given only 1 marks. Again, I am telling you have to write the steps. You cannot write 0.4 into 0.3 is equal to this answer. First you have to write P of what is the given, what is given, and what you have to find. What is given here? What is given here? You take 3 variables Q1, Q2, Q3. Q1 is today's weather, Q2 is tomorrow's weather, and Q3 is a variable which represents day after tomorrow. So I have taken 3 variables Q1, Q2, Q3, where Q1 represents today's weather, Q2 is a variable which represents tomorrow's weather, and Q3 is a variable which represents day after tomorrow's weather. So it is represented as P of what will be a numerator and what is given and what we have to find. Given what? Given what?
Today
is sunny.
Today means you do not use today now. Today is given by which variable?
Q.
Initially we are, see, I had told you, today is given by a variable Q1, tomorrow is given by the variable Q2, and day after tomorrow is assumed by the variable Q3. So can you tell me the probability of dash given dash for this problem? What will be your denominator? What is given? What is given? Please answer.
Q1.
What is given? Q1 is equal to sunny is given, right? Q1 is given. Today's weather is sunny. So Q1 they are given. Today's weather is sunny. Given today's weather is sunny. What will be tomorrow's weather is sunny and day after tomorrow is rainy. That will be numerator. See here. Q1 is sunny. We want to predict Q2 is equal to tomorrow is sunny, comma, and day after tomorrow is rainy. But according to first order Markov model, whether the numerator will have 2 or only 1. Given today, we can predict only tomorrow or day after tomorrow also I can predict.
Only tomorrow.
Only one level I can predict it. Okay, so how it is written, see. So that has to be expanded like this. Okay, so P of, this is okay. Q1 sunny, so today is sunny. I can predict tomorrow sunny into Okay, so today sunny and tomorrow sunny, day after tomorrow is rainy. What is the possibility? So these two, this is written as like this. Like that directly you want, you can write this step also. That is not a problem. Given today is sunny, what is the probability that tomorrow is sunny? And tomorrow is sunny, Q2 is sunny. So how tomorrow, tomorrow and day after tomorrow? So three things, right? What are the three things? Today depends upon tomorrow, depends upon today, day after tomorrow depends upon day after tomorrow depends upon day after tomorrow depends upon
Tomorrow.
what? Tomorrow. So that's why given, see, today is Q1 depends upon Q2, and tomorrow Q2 depends upon Q3. Okay, that is day after tomorrow Q3 depends upon Q2, tomorrow Q2 depends upon today Q1. So like this you have to write the steps, and from the table, given today is sunny, tomorrow is sunny, what is the probability? From the table given today is how it has to be interpreted. P of Q2 sunny slash Q1 sunny means how you have to interpret. Given today is sunny,
Tomorrow
today
is
is also sunny. Yes. So Q1, Q2 is the variable represents today, tomorrow, and Q3 is day after tomorrow. So today is sunny and day after tomorrow is sunny is 0.8. Okay. And today is sunny and day after tomorrow is rainy. What is the probability from the table?
0.05.
0.5. So when you multiply this is the probability that today is sunny, then tomorrow will be sunny, and day after tomorrow rainy will be this probability. Okay, this is how you have to use the first order. So first order Markov chain, even if you have two things in the numerator, you have to go step by step. That's why this first step given the second step. So this is already done. So if you want, you can expand like this. So this is already Q1 sunny is already done here. So you have to take only this part. Q2 sunny and Q3 is rainy. What is that? That's why either you can directly write this step, or you can write this and you can bring this step. So step by step, I want this also. I want for the given statement, I want what is the probability you have to find. Then how you are expanding that probability. Then if you write only 0.05 into 0.8, which is equal to 0.0504, if it's a 5 mark question, only 1 mark will be given. This carries 1 mark, this carries 1 mark, this carries 1 mark, this carries 1 mark, this carries 1 mark. Step by step you have to write it. How you are first you are expanding, then how you are applying first order, and first what is the probability given, this left hand side. You have to write it properly. Given Q1 sunny, we have to predict tomorrow rainy and day after tomorrow sunny and day after tomorrow is rainy. What is the percentage? What is the probability you have to find? Like that you have to go step by step. Okay, I think that's all here the problems. I'll give few more problems later to this. Okay, before this I'll open one more Viterbre algorithm. We'll see problems on that, and I'll give you more problems on the tutorial session tomorrow or day after tomorrow. We'll have one tutorial session. There I'll give few more problems later to it with a different combination. So next one, put the heading Viterbre algorithm, V-I-T-E-R-B-I, Viterbre algorithm. This is an algorithm, you write, this is an algorithm to find the tagging, POS tagging for a word if a word has multiple tags using probabilistic method. Okay, so what is the probability P of? We have already seen, no, how to find the tag for a given word. What are the two transition probabilities we have? Tag transition and word transition probability. So what is tag transition probability? P of? What is tag transition probability? P of? What is tag transition probability? Last class we have seen, no? We have two transition probabilities. Tag transition, secretariat is ready to win the race or something. We have seen.
TI by TI minus 1.
Tag transition probability is TI given TI minus 1. What word transition probability? P of? What is word transition probability? P of WI?
Given TI.
Given TI. For that word, what is the tag? For the tag depends upon the previous tags. Okay, each tag depends upon the previous tags. So we have word transition probability and tag transition probability. So we will be using a Viterbre algorithm to find out the actual tag for the given word if a word has multiple POS tagging, and this Viterbre algorithm uses probabilistic method, and you will be getting a problem on this, and this problem cannot be solved within 10 minutes or 15 minutes. It may take time. If you make a mistake in the first level itself, then the entire problem will be wrong. Okay, so you should be careful when you are doing this, and it will go for multiple steps. So for example, the boy is running. Okay, the boy is riding the cycle. The is a word which has 3 tags. So the first tag, the, if you identified correctly only, then the second tag will be identified correctly. Any third tag, because each tag depends upon the previous tag. If the first tag, if you have made a mistake, and if you identify the as a determiner instead of determiner, if you identify the as a noun or something, then the entire thing will be wrong. Okay, so you should be careful when you are doing this. Okay. Oh, sorry. Viterbi algorithm. I have slides on that. I want to show, or directly I can go to the problems also. Algorithm. Students. Markov. See, this is the graphical representation. So we have in Markov state, we have state transition probabilities given by Tn given Tn minus 1, that is Ti given Ti minus 1, or you can give Tn n minus 1, and the word transition probability, that is P of Wi given Ti. For that given a tag, what is the corresponding word for the given tag? Okay, so here in this Viterbi algorithm, we will be representing as a first thing, given a problem, we will be representing as a graphical representation. Okay, what is that graphical representation? Is each word, we have a start state, end state, and each word will have each represented by one state. Okay, and from the start state, I will be moving here, or from the start state, I can have this as a first word or this as a first word. Okay, so see here, this is A01, A02, or start to end, there will not be no words also. Okay, so here, from here, we'll have possible combinations. Okay, so this is a states we have. So how to draw as a states, I will be telling you. This can be represented as a diagrammatic representation having states and edges, wherein the states represents the words present in the given sentence. Okay, and from the first word, I can go to this word as a second word, or I can go to this word as a second word, or I can go to this word as a first word, anything. So there are 3 words are there. One is representing verb, other is representing the preposition, and other is representing a noun. Okay, so either my first word can be a verb, or my first word can be a preposition, or my first word can be a noun, like that. All from each state I can. So from the second word, once the first word is found, from the second word, it can be verb. My second word can be a verb, or second word can be a noun, like that. It may goes on all possible combinations. So first thing, you have to represent a graphical representation in which nodes represents the states and the edges represents from moving from one state to another state. I will show this example. See here. So see here, this is a preposition. So preposition adverb, race, the, to, zebra. Okay, so these are all the words given. Either this may be this word, or race can be to can be a race, or the can be the preposition, or to can be the preposition, or zebra can be preposition. So these are all the words which is present in my sentence. Among these words, one of them can be to. So these are all the words which is present in my sentence. Among these words, one of the words can be a verb. These are all the words present in my sentence. Among this, somebody wants to tell something? This is here, word given a tag. Okay, so words given the tag. P of, this is a word transition probability, Wn given Tn. Adverb can be a preposition, race can be a preposition, the can be a preposition, to can be a preposition, zebra can be a preposition. So these are all the words present in my corpus. So among these words, all these words can be any one of them. They can be either prepositions. Adverb can be a preposition, race can be a preposition. Similarly, there is a possibility that these words can be a verb also. There is a possibility that this verb can be a noun also. So this is how we have to find out which is the correct tag for the correct word. Okay, so see here, promise to back the bill. Okay, I have a word called promised to back the bill. So this is a sentence given, and for this sentence they have given, for this is promised is, I have taken S1 word, S1, this is S2, this is S3, this is S4, this is S5. I have taken 5 words. Okay, there are 5 words I have labeled as S1, S2, S3, S4, S5. And this promised has how many tags they have given? Promised has how many tags? The word promised has how many tags here? They have given how many? 2 tags. The word to has how many tags? This is a tag label. VBN is a verb with as a third participle. Something will be there. You can check in that 45 tag list. Okay, so 2 tags. Verb with past tense, present tense, all this like that. Okay, to is a tag label given for preposition. I guess TO, capital TO. So to this word TO will have how many tags is given in this problem?
1.
1. Back is a word which has how many tags? Totally how many tags is given here? How many tags is given for back? Word back has how many tags? How many tags given for the word back in this problem? It can be a verb, it can be a noun, it can be RB, it can be JJ adjective. So how many tags it is given for back totally? How many tags we have for back?
4.
4. For the word there has how many tags given in this
2.
problem? 2. For bill?
2. 2.
2. So totally I have 5 words. Each word is represented by a label S1, S2, S3, S4, S5, and which first word has 2 tags. They have given first word has 2 tags, second word has only 1 tag, third word has 5 tags, 4 tags they have given, and for they have given 2 possible combinations, and for bill they have 2 possible combinations. So among these 2 possible combination, only one can be for, only 1 tag can be given for the word. Only 1 tag can be given for the word. Among whether both the tags can be assigned to the word promised in the sentence? No. Only 1 tag will be assigned for the word. Only 1 tag or both the tag? Only 1 tag will be assigned for the word promised. So okay, 2 has only 1 tag, so not a problem. For back again, what is the problem? The word back has how many tags here? The word back has 4 tags. Among the 4 tags, only 1 will be assigned. Yes or no?
Yes.
For this sentence, in the sentence, for the word back, given 4 tags, only 1 will be assigned. Yes or no?
Yes.
1 will be assigned or 2 will be assigned?
1.
1. For I have given 2 possible combination. Among these 2, only 1 is the correct. Any one which either the can be determiner or it can be a noun in plural or something, NLP. And for bill, it can be a noun or a verb. Among these 2, only 1 is possible. So totally how many possible combinations you will be getting it? Tell me. 2 to the power 1, to the power 4, to the power 2, to the power 2. So totally how many possible combinations we will get it? Different combinations. How many combinations? Among this, only 1 combination is the correct combination. So how many possible combinations you will get it for this? Here 2, I have here 1, here I have 4, here I have 2, here I have 2. So 2 to the power 1, 2, 2 to the power 4, 8 to the power 2, 16, 16 to the power 2. So 16 into 2, how many combinations? So 32 possible combinations I will be getting it here or not? Yes or no? Whether I can have 32 possible combinations? Among the 32 possible combinations, how many combination will be a correct combination?
1.
1 combination will be a correct combination. What is that combination? This is the correct combination. So how to find this is the correct? So I have 32 possible combinations for promised having 2 tags, 2 having 1 tag, 4 here 2 tags, 2 tags. So among the 32 combinations, promised is a VBD, 2 is 2, and from here back they have taken as verb. It's a correct combination among the 4 combinations, and the is a determiner, and bill is a noun. So whichever is given in the darker line, that is the correct combination. So among the 32 possible combinations, there is 1 combination which is the correct combination, that is VBD to 2 to VB to DT to NN for the given promise to back the bill. So how I got this? This is how we are going to find it. Viterbi decoding method. Okay, it uses Viterbi decoding method to find the correct possible tag for the given combinations, okay, in the given sentence. Okay, so that we will see through it. Okay, so you have to walk through all the states and find out which is the correct combination. Okay. Okay, we have to find out all 32 combinations you have to find out, and whichever has the highest probability, word transition probability, tag transition probability, you have to find out, and you have to multiply, and whichever word has the highest probability, that will be taken. Okay, so here we have, this has 2 tags, this has 1 tag, this has 4, this has 2, this has 2. So totally we have 32 combinations. Among the 32 combination, one combination will be the correct combination. That correct combination is this one. It is not that VBN to 2 to RB to DT or to VB. Like that we have 32. If you take from these two, if you start from VBN, you start, we'll have some combinations. From VBD you start, we'll have some combinations with all traversing through all possible combination to all states. Okay, so now we will start off with the problems of iterable decoding so that it will be easy for you. Problems, where it is. I will teach you only one problem. Please make a note of your problems are not there. 1 minute, I have written. One minute, students. I'll show the problems. I have written and I have POS tagging. Somewhere I have downloaded. Okay, wait. I'll take the previous year's problems only. Iterable algorithms. See, one problem, I cannot finish it by today. It may take 1 hour to finish. I'll be solving one problem. Please have the calculator with you. You have to solve and you have to tell me the answer then and there for all the steps. Okay, take down this problem in your notebook. Can you all able to see the screen, students?
Yes, ma'am.
Yes, please make a note of this problem. At least one problem, please write it in your notebook. Your questions will be like this. You'll be getting a question on iterable algorithm for POS tagging. Can you able to see, or I have to zoom a little bit? Is it fine now? What is HMMS? Hidden Markov model. That is Markov chain. Each state depends upon the previous state. Suppose you want to use Markov model tag to tag the phrase. What is the sentence given here? What is the sentence given here?
The light book.
Very good. The light book is a sentence they have given. So how many words I have? How many words I have? 3 words. So first word label with S1, second word label with S2, third word. I'll tell you. First you copy the problem. Copied. Can I scroll down? See, later on I will not show the problems. If you have the values only, you can able to solve it. Please make note of these values. Don't waste your time. If you don't want to copy, at least I can move to the problems. And I am going to explain only one step. Remaining all steps you have to do by yourself. And I'll ask anyone for the answers. Don't tell I have not copied the problems. Can I scroll down? Yes or no?
No.
No, okay. What is this first part? After copying, can you tell me from here what you're going to infer first? Then we'll go to the problems. Finished? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tag transition probabilities are there, and 1, 2, 3, 4, 5, 6, 7 word transition probabilities are there. Done? Yes or no? Please respond, students.
Yes.
Yes.
Yes, ma'am.
Okay. So before starting the problem, what you have analyzed in this problem? Can you tell me what and all is given? There is a sentence given. Yes or no? What is the sentence to be whose tag has to be identified? What is the sentence given?
The light book.
Please respond. There is a sentence given. For that sentence, we have to find the tag. So the light book. So the light book is a sentence. So how many words we have in that sentence? Please be active. How many words I have in the
3
sentence?
words.
3 words. The first word we assume the, second word as light, third word as book. Okay, so you give a label for the, it is S1. Above the you write S1. In your notebook above the you write S1. Please give the label. Okay, for light you give S2 as a label. Wherever I give S2, when I talk about S2 in the problem, it is about light. Okay, and S3 is book. So I have a sentence, the light book, which has 3 words, S1, S2, S3. The first word is the, second word is light, and third word is book. So can you tell me how many possible probabilities they have given in the problem for the first word, the? Can you?
2.
2. What are the 2 possibilities they have given? The as
Determiner and noun.
Very good. Determiner or the as. Among these two, the should have only one probability, only one tag, right? Either it should be
Noun or determiner.
very good, noun or determiner. So among these two, I have to find one. For the second word, light, how many combinations they have given?
3.
3 combinations they have given. Either they have given light as a noun, this probability, light as an adjective, this probability, and light as a verb, this. Among these 3, light should have only one. Which one is the correct? We have to find out. And third word is book. So book has how many probabilities?
2.
2. Very good. So what is the 2 probabilities they have given for the book? Noun and
Noun or
verb. So among these two we have to. So what is this first 2 lines represent? It's a word transition or tag transition probability.
Word transition.
Word transition. Given WA, given TI. Next you come here. This is the tag transition probability. Determiner as a verb. Okay. TI given TI minus 1. Okay. Is this? These are all what probabilities? The next 4 lines belongs to what probability?
Tag
Tag.
transition.
We have 2 probabilities, right? P of WA given TA into P of TA given
EI minus
minus 1. Okay. So this is how it is given in the problem. So they will be given a sentence. They will be given the word probability, word transition probability. They will be given a tag transition probability. And they will be asking you to use the Viterbi algorithm. Okay. What Viterbi algorithm uses the hidden Markov. That is first order Markov. Each state depends upon the previous state. This is an algorithm which uses the state transition probability and the tag transition probability and the word transition probability to find the tag for the given word. So first what they are asking, you can use a table to show the steps. Assume that all the conditional probabilities, whichever probabilities which is not mentioned here, to be 0. So whatever probabilities which is given here, you can take it. The remaining probabilities which is not mentioned here, you can assume it as 0. That is the first condition given in the problem. Second condition, also assume that all the tags have the same probability to appear in the beginning of the sentence. So in the beginning of the sentence, all the tags will have a same probability. That we will see later. So this is how the questions will be given. So the question will start here, will end here. So first thing what you have to do is, okay, so first thing you have to draw the tag transition probability matrix and word transition probability matrix. Okay, so we have tag transition probability, right? How many tag transition we have and how many word transition we have? How many tag transition we have and how many word transition we have? In the given exam, in the given problem, how many word transition probabilities, how many probabilities are given? 2, 5, 6, 7 are given. Okay, first you write the heading word probability matrix or word transition matrix, and first step you have to convert that values in the form of a matrix representation that carries marks. That is P of, what is the word probability matrix or transition matrix formula? P of Wi given, Wi given, P of Ti. Okay, so please write the first heading as word probability matrix or word transition matrix. In bracket you write P of Wi given Ti. So draw a table. So how many Wi's I have? How many words I have? That will becomes the rows. How many Wi I have? How many words I have? How many words I have?
3, ma'am.
3.
So that becomes the column. So Wi will be on the y-axis column. The light book, you write it here. Can you all able to see the screen? Is it visible in the screen?
Yes, ma'am.
Yes. And how many tags I have totally in my given problem? What are the possible tags I have? Determinant, noun, adjective, verb, any other thing? Determinant,
No,
noun,
ma'am.
adjective. No. So that becomes the columns in my table. So Wi given Ti. So Wi will be the numerator part will be in the y-axis and the denominator part Ti is in the x-axis, and put the values. So the as a determiner, what is the probability given? The as a determiner, what is the probability given in the question? That's why I make you to note down
0.3.
question. Okay. So the as a noun,
0.1.
0.1. The as a adjective, the probability, the as a adjective is what? It is not given in the problem, right? Any probability is given?
No, ma'am.
No. So what is given in the problem? One statement, if the probabilities are not there, the probability should be
Assumed as 0.
a 0. See, assume all the other conditional probability not mentioned to be 0. So you mention 0. So if you fill this table first, Wi given Ti. Similarly, you fill Ti given Ti minus 1. What to Ti given tag, you write the tag transition probability, write tag on other side, other tag again tag on the other side. Okay, Ti is one side, Ti minus 1 is other side. Determinant given as determinant. That is numerator part in the y-axis and the denominator part in the x-axis. Ti given Ti minus 1 and fill this table. So next class we will be solving the problem. Okay, we have to draw this diagram. I told you, there I show some diagram, right? 32 combinations like that. For this you have to draw this diagram like this. Then we have to solve it. I will tell you how to solve it. Okay. It will take 1 hour time to solve it. Okay. At least you fill the word transition and tag transition probability alone. Okay. We will solve tomorrow's second hour class. This is time now to, because second hour you have class, right? Can we stop it here?
Yes, ma'am.
Yes, students. Okay. So this till here, please finish off and come tomorrow. Please be ready with your calculators.